diagram below shows a heavy block of mass 100 kilograms sliding down a rough inclined plane. So it's actually moving this way. It's moving down it, okay? But there's a constant force applied on the block parallel to the inclined plane as shown. So it is actually being pulled up with a force, okay? The block slides down with a constant velocity, which again shows that acceleration is 0, which means that our net force is 0. And then it tells us that the magnitude of the kinetic frictional force between the block and the surface is 266 newtons. So we know that there's a force of friction, which equals 266 newtons. Okay, that's quite cool. Now it says, friction is a non-conservative force. What is meant by the term non-conservative force? Okay, there are two ways you can answer this. The first way that we can answer it is by saying that it takes energy out of the system. So therefore, it does not conserve the energy principle, which says that energy will be conserved. It can only be transferred from one form to another, cannot be created nor destroyed. Okay, that's the one thing. The second thing to realize is that friction is dependent on the path. It's dependent on the path, and non-conservative forces are dependent on the path that they travel. So the longer the path, the more we will experience this force, okay? In other words, if I had to say to you, what is the force of gravity that is acting on this object, like here, okay, right? It wouldn't matter, wait a minute, it wouldn't matter if let me show you. The force of gravity is in this direction, towards the center of the Earth. This here is the distance that the force of gravity acts over. It doesn't matter how far along the slope or how long the slope is. That is the direction and the displacement that the force of gravity acts over, because force of gravity only acts downwards, okay? So similarly, if you, for example, decided to jump out of an airplane, and let's pretend that's the Earth, and let's say you're jumping really high, you're like that crazy dude that jumped out of the top of the atmosphere. It doesn't matter if you do this, okay? Because the force of gravity is pulling you straight down. Okay, so that there is important, whereas the force of friction actually follows the path that you're traveling in, and therefore it is non-conservative. Now it says, write down the net work done on the block. The net work done on the block. Well, we know that, it says write down, we know that the work done is equal to delta K. Okay, we know that the net force, we also know that delta K, work done, is equal to F delta X. Okay, so the F is 0, therefore there is no work done. So the correct answer here is 0. Now it says calculate the magnitude of the force, and by the way, this is the net force, the net force. Calculate the magnitude of the force. Okay, so now they want the force F. So what they were hinting when they asked us to work out what the network was done was that we could realize that F net was equal to 0. Therefore, the sum of all the forces acting on this object is going to be 0. But let's talk about what the forces are. And let's just draw a free body diagram to think about what all the forces are that are acting on this object. Do you agree that there is the force of gravity going down? Here is my slope. Okay. There is big F, which is pulling it up. There is the force of friction. Force of friction. And the force of gravity can be broken up into two forces. The normal force, there is a normal force, F normal. There is the force of gravity perpendicular, which is the same as the normal force in size. And there's the force of gravity parallel, FG parallel. Okay, so now if that's the case, we have this force, and this force. Those three forces together are acting on the object to actually make sure that the net force parallel to the surface is 0. So we've got the force of gravity parallel plus the force applied plus the force of friction. Now, again, I hear somebody screaming about the fact that some of these in the opposite direction, so how dare I do pluses? But the definition of a net force is the sum of all the forces. So if you don't like writing it like this, but you need to show that it's the sum of all the forces, what you can do is you can say right at this point at the beginning that let the direction that we positive be down the slope. Then you've got FG parallel plus minus the force applied plus minus the force of friction. But grade 12s, you need to show that you know that the net force is the sum of all the forces. You need to show that somewhere in your calculations so that you get the marks for it, okay? Otherwise, you're not going to get the marks. So FG parallel, we need to work out. This little angle here is 25 degrees. This here is 100 times by 9.8, okay? And we want FG parallel, so we're going to use SOHCAHTOA. This is the opposite side. That's the hypotenuse, so we're going to use sine. So we're going to go sine of 25 degrees equals FG parallel over 98. Therefore, 98 sine 25 degrees equals FG parallel. We're going to go 98 times sine of 25, close bracket, equals, and that becomes 41.42. So that's 41,42 newtons is FG parallel. And let's just go back there. I'm just going to show you something. Notice that you always round off to the second decimal place. So that means you look at the third one. Okay, you don't look up down here. We just look at the third one, and that is a 6, which is bigger than 5, or 5. Yeah. So therefore, because it's 5 and bigger, we round that up to 2. So it becomes 41.42. Okay, so now we know that that is 41,42 plus. They want this, so this becomes minus the force applied, minus the force of friction, which they've given us is 266, and that equals 0. Okay, so let's take everything across. You get 266 minus 41,42 is going to be minus the force applied. Okay, 266 minus 41.42 equals 224.58. 224,58 equals minus FA. Therefore, the force applied is equal to minus 224,58. And what did they do? They asked for the magnitude of the force. They just wanted the size. So you can just ignore that. So that is the size. And remember, you always have to put your units in. If they hadn't asked for the magnitude, if they just said calculate the force of F, you would have had to say that it is 224.58 newtons up the slope. But they didn't. They just asked for the magnitude. So therefore, we now have that this is 224,58 newtons. Right, now they say if the block was released from rest, okay, so our initial velocity equals 0, and it's without the force F being applied. So the force F is not there, okay? It moves 3 meters down the slope to the bottom of the inclined plane. So it moves 3 meters, 3 meters. And they want to know to calculate the speed of the block at the bottom of the inclined plane. Do you agree that if the force applied wasn't there, then the resultant force on the object would be this 224.58 newtons, because that is the size of the force of the sum of these two forces, the force of friction and the force of gravity down. Force of friction and the force of gravity down, right? That there is equal to 224.58. So now we have F net is equal to 224,58. Right. We have the initial velocity 0. We have delta x is equal to 3. Do you agree we could work out the final velocity in two ways? And they don't say which way to do it. They don't say you have to use energy methods, and they don't say you have to use equations of motion. So we have either or. I'm going to go with the energy method because we're doing questions on work, energy, and power. We know that F net delta x equals the work done, which equals delta k. We have the net force, cha-ching. We have the delta x, cha-ching. We have the initial velocity, it's 0. So can we work out the final velocity? Yes, because we have mass. Yay. So we can say 224,58 times by 3 is equal to half times by the mass of 100 times Vf squared minus 0. Okay, because initial velocity is 0. So therefore we can pop this in our calculator and we can go 224.58 multiplied by 3 equals 673.74. 673.74 is equal to 50 Vf squared. So we can divide both of these sides by 50 and then we can square root it. So let's do that. So we're going to divide it by 50 and then we're going to square root the answer and we get 3.67. So the final velocity is 3.67 meters per second. And they've asked for speed, which means we don't need to give direction. So therefore the correct answer is 3.67 meters per second.